I'm here with Wes Wheeler.
Whoa. Again, thank you, Tom, for inviting me to speak to you today a little bit about 70E and a little bit about risk assessments. I'm Wes Wheeler. I'm the Executive Director of Safety for the National Electrical Contractors Association, and I've been with NECA now a little over 10 years. Served a couple of terms on the NFPA 70E committee, and I work well with the other NEC, the National Electrical Code Committee, currently on a couple of committees there as well. Mm-hmm. But it's one of the things that, as we talk about electrical safety, and many times it's been said that when somebody gets injured or somebody say they get shocked, really that's an indication that they did not do a proper risk assessment. Yeah. Because if they had done a proper risk assessment, number one, they would have known what their qualifications were in order to perform the task. Right. Number two, they'd have done a risk assessment to determine what is the level of PPE, the insulated goods that I'm supposed to be wearing to protect me from the voltages that I'm going to be exposed to. Right. So if I did become in accidental contact with them, I would be protected by the rubber goods, the insulated gloves that I'm in. So, what it tells us is when somebody gets shocked that they didn't do a risk assessment that they were supposed to. And that lends itself to say, this person is not qualified.
So it gets to the core of a qualified person. Now, the concept for this session for Shock Week, and I still say we need to do an IEEE paper together.
Oh, definitely.
But you brought this topic up a while ago. You and I were talking, and you made the statement to me. You said, Tom, quite often on job sites, on projects, the risk analysis that you did before you started the project changes while you're in process. And how we adapt to those changes is really important. And recognizing, and remember, we were brainstorming, and we talked about it could be a weather change, it could be an active shooter, it could be that your tool didn't work, right, and you had to change the tool, and all of those, everything around that project is a part of a risk assessment. But we have to realize going in that your risk assessment has to be continuous.
It does. It has to be ever changing. And I've got two examples I'm going to share with you. And the first one is going to be a little bit, and it goes back to the planning, the job hazard analysis. And we're looking at the task, we're looking at what we need to do. And I'll never forget one of the first projects that I ran years ago. I was a project at a roofing plant, and we were given part numbers by the engineer for tap boxes to be installed on an existing busway. Okay. So they give us a part number. They give us an opacity rating for that tap box. And so we say, okay, it is 400 amp busway. This is the tap box for 400 amp busway. We order it, we get ready. And when it comes time for the shutdown, the intent was to take a long section of busway and take two sections out so we could then have three separate feeds. Right. So it does, it shares the load, it distributes the load. So we get the two sections taken out and open up the box for the 400 amp bus tap box to go in. And it doesn't fit. And it doesn't fit. It's like, okay, well, and then the first thing people say is, well, I can't do this, I can't complete this. It's like, timeout. We've got to realize that this plant has to go back in operation at 3 o'clock this afternoon. And we need to come up with a solution, be it temporary in nature, make sure that the solution is going to be safe, make sure the solution is going to work, and let's solve the issue at hand to get the plant back up and running. And then we'll back up and see what's wrong. Did they ship us the wrong box? What happened?
Right.
And so consequently, we were able to temporarily wire things, get things back distributed the way they're supposed to. and got the plant back in operation, but then contacted the manufacturer, contacted the engineer, and he says, no, that's the part number. He says, that's the ampacity rating of the bus. This is what it is, and this is what you need to get. And I called the current manufacturer, and what had happened in the 25, 30 years since that busway had been installed is they had actually increased the rating from that busway from 400 amps to 600 amps.
Wow.
So I needed a 600 amp tap busway tap box.
Right.
And once we identified that there was a change in ratings for that particular one, we got the right piece in there. We scheduled another
Right.
outage. We put it in, and it's one of those things that as you're going through a project and you're performing a risk assessment, what are the things that can happen? What are the things, it's always job hazard analysis, and you're looking at, what can go wrong? What are some of the things, and how do you adapt and overcome some of those scenarios?
Right. Yeah.
Okay.
Yeah.
And the other scenario that I think is even a better example when we start talking about when it comes to 70E, the incident energy analysis, and somebody is going to do an arc flash study on a plant, an industrial plant, for instance. And let's just say that we have a 3,000 kVA transformer outside,
Yeah.
and it's got parallel feeds coming in to feed main switch gear that was installed probably early 60s.
Yeah.
Okay. Well, the engineering company came in and did an arc flash study based on the main switch gear, which included a 4,000 amp switch. And their study, they said everything downstream in the plant went through the 4,000 amp switch, which meant if you're going to look through the curves of the fuse and you look through the arc flash and the incident energy calculations and stuff, we're going to base everything on coming from the transformer to the 4,000 amp switch.
Yep.
And then downstream.
Right.
From there. Well, that's the way that was reflected in the arc flash study that was given to us as part of the project that we were working on. We were actually installing an Eaton arc mode reduction breaker.
Oh, okay.
Between the transformer and this gear, because that was to control future issues.
Right.
We're providing the latest technology.
Yeah.
But the whole point was when to proceed, first thing we had to do was turn power off. So the intent was to turn the 4,000 amp switch off.
Okay.
And at that time, you think some things happen. Everything in the plant we went through shut down as much as we could. But when we open the 4,000 amp switch, we expect the rest of the plant to go dead.
Yeah.
Or, become de-energized. Well, then we look at each other and there's still lights on in the building, in the room that we're in. And we're like,
something ain't right.
I just turned the main off and we still got lights. So what's wrong here? And then we listen to the distance and there's still fans running in other parts of the plant. Wow. And there's other motors running in other parts of the plant. And we looked at this and okay, here's the drawings. Here's what the engineer gave us to work with. And it shows that this is ahead of everything else downstream.
Mm-hmm.
When in reality, this 4,000 amp switch was solely for the motor control center that was behind us.
Wow.
You remember a 6 disconnect rule that used to be in the code book?
Yeah.
And it says that as long as I could have no more than 6 disconnects in a service entrance.
That's right. Yeah.
I could have 6 switches.
Right.
4,000 amp switch, 5 other breakers over here in the next section next to it.
Yeah.
To feed other parts of the plant.
Wow.
No more than 6. Okay.
Correct.
Well, let's proceed a little bit further now. Now that we identify the problem, and the first thing we did, anytime that something changes, it's one of those situations where if conditions change within a project, before you get down the road, if you can stop what you're doing and have a contractor, host, employer get together and say, hey, look, in order to proceed, we've got to make everybody aware of what we just found was an inconsistency in the information that we had to do this job. which means if there's an inconsistency in the information we had, our risk assessment, our job hazard analysis now is changed.
That's right. Yeah. Oh, yeah. You're
And
absolutely right.
if we don't,
Yeah.
so whatever we do from this point forward is going to have a direct relationship on how we're going to manage that.
Right.
And then, oh yeah, by the way, we turn off the individual breakers for a total of 6 breakers, but guess what? There's still lights on in the room.
That's insane.
There's still
Yeah.
lights on in the room, and I'm like, why is there lights on in the room when all the breakers are turned off in the switchgear?
Yeah.
And a maintenance worker comes up and says, we used to have problems with this when we turned the power off and we lost lights. So years ago,
We.
we decided that we would tap off this and set a disconnect and a 10 kVA transformer and a little lighting panel so we could feed lights in this room. So if we did turn the power off, we still had lights in the room. And I'm like, let me get this right. You tapped off with a number 8 wire on a 4,000 amp bus. It's coming off a 3,000 kVA transformer outside.
Wow.
I'm not really sure that that really complies with the NEC tap rule.
No, it does not.
You
And it's
know?
definitely not on the drawings.
And it's not on the drawings anywhere
Yeah.
that represents that's what's there.
Wow.
And so, those are the kind of things that as you're going into a project, when those conditions change, you got to know, okay, I can't just proceed as normal. I've got to stop what I'm doing.
That's right.
I've got to, assess the situation and do another risk assessment on, okay, here's what's going to change now. Here's what we need to do. And, after I get the engineer on the phone, after I get the maintenance supervisor on the phone, after I get the plant manager on the phone, and everybody comes down and we have a meeting and we go over this change. We're already now 2 hours, 3 hours behind schedule
Yeah.
in the shutdown and changeover. But
Yeah.
if we can't come to an agreement, we can't move forward.
That's right. That's right.
And once we identified the problems, we identified that, and I said, well, here's your arc flash study. It's not worth the paper that it's written on, but now that you know what really we have, now you can do a new one, and it's going to be reflective of the new switch that we're putting in line.
Because you have to update the one line diagram.
You have to update anytime that you make a change.
Absolutely.
Then the one line diagrams are
Yeah.
supposed to be changed and updated. And to that point, part of the project, because as we said, I've said it commonly, is that technology has a way of really enforcing safety a lot of times. When we start looking at, and I'm going to go back years ago, this is before Eaton, Ball, Cooper, Busman, and the greatest thing that came out was time delay fuses, and things that allowed inrush
Oh, yeah.
currents.
Yeah. Yeah. Yeah.
And
Yep.
those type of
Yep.
protective devices that operated properly. And then after we went from there, then we went to, now we got, instantaneous circuit breakers. We've got, HVAC equipment that's going to be protected by HMCP panels and breakers and all.
That's right.
And you have to do that. And then we look at, the technology that's there that the NEC years ago said, now it was anything over 800 amp, we have to have arc mode reduction, have to arc flash mode. So we have to put in something in there
Yeah.
that's going to help protect the system.
Yeah. 24087 and 24067 focuses on 1200 amps and above.
Yeah.
We're trying to move it to 800 amps. Still haven't
Yeah.
been able to get that done. But you're right. In that having that device upstream,
Yeah.
you can turn that on. In fact, that brings up a case. I did an IEEE paper with Ken White.
Okay.
He worked for Olin Chemical, and it was. They had a project which goes to this whole dynamic thing,
Yeah.
right? So in their project, they were working on a piece of equipment. They needed to pull conductors out,
Yeah.
and they had a lineup where each column, the column that they were working in was they established. I'm not going to say they established electrically safe work condition. They de-energized
Okay.
that column, but everything else was energized, right? Now it's still open inside, right?
Yeah.
So they identified to pull that conductor out of the cable tray.
Okay.
They pulled it out, in other places, and to pull it the rest of the way, they were going to use rope because non-conductive, the whole bit, right?
Yeah.
It was a Friday, just like you said, it's late, right? You want to get home, but it's late on a Friday. they were trying to pull it out with the rope and the rope wasn't working. So what do you do when something doesn't work? You think on your feet and you go get a come along
Yeah.
that has a chain.
Yeah.
You hook it up and it starts to work. And you're
Yeah.
like, okay, great. Now, what they didn't do was, now they did a risk assessment beforehand. They had an arc reduction maintenance switch upstream. They
Yeah.
turned that on. They locked and tagged it out. They followed all the procedures. They had only the qualified people. They knew what tools they were going to bring on. They went through a job planning, the whole bit.
Yeah.
And then the one solution wasn't working. They changed the tool. Okay. Instead of doing a risk assessment again,
Yeah.
instead of sitting down and saying, let's take a look and identify the hazards, the chain would be a hazard, estimate the likelihood of occurrence of an injury. You're using a come along, the chain is going to go down. If they would have said, look, we have to be mindful of this chain, it is conductive. We have to pay special attention to it. Grab the end of it. You're in charge of that, Wes. You're going to be on now, and you're going to be in charge of this end of the chain while we're pulling everything out, right?
Keep it safe.
Keep it safe, right? They estimate the potential severity, injury, damage. I'm just looking at the definition of a risk assessment.
Yeah.
So they didn't do any of that. The chain went down and it went over and it touched an energized bus.
Oh.
The plant went out, okay, because they took the arc reduction maintenance switch was way upstream.
Yeah.
Okay, it was up there on the main. So everything went out. The only thing they saw in that equipment where the arc was what occurred was a little blue flash. In fact, nobody else in the room knew that they I mean, when you kind of draw the conclusion, but you're like, well, did we do this, right?
Yeah.
Because in their mind there was nothing that they were doing that should have caused it. But the outage occurred, and it was because they simply changed the tool because the first tool wasn't working.
And they didn't perform the risk assessment on.
Right.
And the way that I look at it, and always is, it's like it goes back to a plane that crashed years ago. Anytime that you find a plane, there's a manual, and what they've done is they've gone through all the scenarios that they can possibly think of. If this goes bad, do this. If this goes bad, do this. And there's like 3 redundant systems. But so what's the chances of 3 redundant systems going out at the same time?
Yeah.
Well, pretty good if the fan blade cuts all 3 of them.
Whoa.
And all of a sudden now we got a plane that's flying without hydraulics. How do we control it? So that was a plane that crashed in Iowa years ago. But what I'm saying here is that we always generally go back and say, hey, if we can plan for any possible contingency, then we've conducted our risk assessment to the nth degree. They didn't do that here. They didn't identify that. And like you say, from the fact that the arc mode reduction breaker did its job because it kept the arc flash and the damage down to a minimum.
Yeah.
The size of the workers.
Size of a dime. They did
dime.
not have to replace the equipment.
Yeah.
They didn't have to do anything. I got the phone call from Ken White, and Ken said, Tom, I want to thank you. I said, for what? He goes, for the technology.
And the technology, as I said, we're developing safety technology now that's going to, we just got to be careful that our workers don't become too over dependent on it.
Yeah.
But I think that once they grasp and those arc mode reductions, I mean, you have situations where in some rooms they can be automatically set when somebody walks in, a motion detector can automatically.
Oh, absolutely. Door opens.
It goes in. Or if I'm going to be working in that or in another area of the plant, I can do the selector switch and say, hey, I want you an arc mode reduction until we get finished with the work. Those are all components that have to be identified in that job hazard analysis and that risk assessment, just to be able to do the job. And then we're talking about, okay, now we're going to do the job. We're going to do a shock risk assessment. We've got to do an arc flash risk assessment. And before we move on to, to actually starting the work and completing the work. So we see all of those factors that can change. And it goes back to, I think we talked about it before, communication.
Yeah.
And at any time something deviates from what the intended plan is, we need to communicate to all parties involved. Because if we don't communicate that, then somebody's left out of the chain of command, or somebody's left out of the chain of communication. They may not be aware of what's going on, and they may walk in and do something that is totally against what the change in plans is going to ultimately be.
Yeah.
So I think that, we're talking risk assessments here. We're talking about what are the things that, that what's the probability? Okay. When we start looking at, the probability that something's going to go wrong. Well, we can say that it's very low probability to very high probability. It just
Sure.
depends on the task of
Yeah.
what we're working on.
Yep.
And
Yep.
you mentioned about pulling the wires. I mean, I know that there's some situations there where some people say pull wires to identify them, and I'm like, I don't want to pull a
Oh,
wire.
no, no, no.
I
Yeah.
don't want to pull a wire to identify it unless I know 100% that they're open on both ends and it's de-energized.
That is exactly. You
know,
don't
and-
tug on
and-
anything.
And you don't tug on
Absolutely.
anything until you're very aware. And when we talk about now in NFPA, we have a point of work requirement for testing. And that's not an induction tester. That is a point of work verification process
Yeah.
that we have to verify that the power is off
That's
where
right.
we're working at.
Yeah. Yeah. Yeah.
So how do you do that in an insulated conductor if you're not using an induction tester?
No, that's a good point.
Huh? I mean,
No, that is a very good point.
so
Very
it
good
goes
point.
back to you're going to go up there and pull on a piece of wire. No, I don't think that that's the proper way of doing it. I mean, granted, if you have to cut the wire, there's tools out there now that enable you, and we talk about safety and technology.
Get out of the
Now,
red zone.
we want to get out of the danger zone here,
Yeah.
and you're going to get out of the arc flash zone because you're going to do an arc flash assessment. But I have a tool now that has Bluetooth capabilities, so I can set it up and I can operate it remotely to cut the cable. If by chance I am accidentally cutting the wrong cable
Yeah.
and it's energized, then the tool blades is going to short out. The tool is going to be damaged. We're going to replace the heads on it.
Yeah.
But the most important, you're alive, I'm
Yep.
alive,
Absolutely.
and we don't have
right.
we don't have any other damage done to any other equipment.
That
That's
is
good.
absolutely right.
But yet, if I'm up there pulling on something, and I pull the wrong wire, maybe I pull it out of a lug in a panel somewhere on the other end because I'm not realizing where I'm pulling it. Now I've just caused a three-phase system to go to
Yeah.
single phase. And have you ever seen what happens when a three-phase motor 4160 goes from three-phase to single phase?
It ain't purdy.
It's not, because they estimate the overvoltage in that system to be somewhere around 10 to 13,000 volts
Oh, absolutely.
by the time it actually arced inside the equipment from going single phasing.
Wow.
So you can see that if you don't follow the proper guidelines
yeah.
and take the special precautions in doing your risk assessment and then the actual work itself, I mean, the consequences of your actions can destroy gear, can destroy equipment,
And hurt people.
and hurt people and people that's going to be in the areas.
Yep.
And we talk about all the time is that for many of the electrical contractors that are struggling in this market to keep their doors open, to keep their employees working,
Sure.
and keep everything else, man, a major incident or a major foo like that is going to could cause a company to go out of business.
Oh, absolutely.
Yes.
So let's take a look. 110.3 is your
Mhm.
electrical safety program.
Yep.
H is the risk assessment procedure. And it tells you have to do H 1 through H whatever, 3, I think it is.
Yeah.
So 1 is your risk elements of the risk assessment. The first one was identify the hazards, and we just
Yeah.
talked about that. Now,
Yeah.
the key thing, and you talked about communicating. What I heard someone say in a class I was in one time, or I can't remember where I heard it. I think it was a class. The instructor said, never assume all hazards have been identified
Mhm.
and that all of the controls are in place. And I thought that was an interesting statement because, I mean, in many other aspects of things, you never you never want to assume. You want to always verify, right?
Yeah.
But his thought process was, he said, and it was specifically, and I think he was alluding to the dynamic risk assessment
Yeah.
that we're talking about, that you always have to assume that maybe, just maybe, not all of the hazards have been identified, and maybe the controls, not all the proper controls are in place. So what do we do from an awareness perspective to understand the hazards? We do the site reviews.
Yeah.
Right. You go to the job site. You say, look, I mean, I'd see the best. That just said, this is where we're going to be working. You look around, you look up, you look down, and you get a good assessment of the entire area.
Mhm.
Right. We do toolbox talks.
Yeah.
and that raises awareness and incidents like
Yeah.
what you shared, incidents that I shared are great toolbox talks because we can learn from each other, and then that just raises the awareness, right?
Yeah.
Safety conversations like this content that we're creating here, content that you have on your blog or
The safety pod,
your safety podcast. Yep.
Yeah.
Which I want to make sure people know
Yeah.
how to get to.
NECA Safety Roundup. You can get to it through the NECA website, which is www.necanet.org. Look under programs and look under safety. You'll see that we have a web page there for safety resources, and the NECA Safety Roundup is one of the top listings that's on there. And we have, we've been doing it now for about a year and a half. I mean,
Yeah.
you have much more experience, but I mean, I know we're not here to talk about the safety roundup.
Well,
but
no, we are.
We look forward to having you on
Yeah.
our roundup.
I would love to be on.
You're
Yes,
gonna be on.
absolutely.
But it goes back to, going back to what we're talking about here.
Yeah.
Is staying on top of it and making sure that, we are communicating all of the different things that could potentially change, and this could happen, and it's, you mentioned about doing assessment on that, and one of the things that just came to mind literally as we were talking
What?
is I remember being in a city last year, and one of the stories that came across the news feed was a electrical installation where they had multiple runs of conduit with multiple runs of conductors that came out of a main switchgear that went up overhead in some racks
Yeah.
and went into the building to feed a parking garage and an apartment building.
Okay.
You would think that looking at it, it probably looked like a fairly decent installation, but you cannot hang that much conduit with that much copper on a toggle bolt in a sheetrock ceiling and expect it to hold the weight.
Wow.
So just think about it. If I'm working in front of that switchgear and I'm doing whatever work it is, and then all of a sudden the unforeseen, the things that we had not, you had not counted,
right?
What's the chances of all the conduit come falling out of the ceiling over the gear? I mean, that would be I tell you, if that happened to me while I was standing in front of that switchgear, I probably would have had a heart attack right then and there. Because it's one of the things that, and that goes to show you the unforeseen things that can happen.
Yeah.
That you don't anticipate.
Yep.
Are the things that you really, let's build some capacity in there. What are some of the things that we could do to possibly say, number one, if you got an installation, maybe you want to critique that installation. How is this installed? What could I do here to protect me while I'm here?
That's right.
Maybe I want to put a scaffold or something else up underneath there to protect the workers in the area that they're working in.
We do that. We do that when we work in ditches and whatnot, right? You shore up the sides. You won't get down in there unless you shore everything up.
That's true.
You wouldn't know that unless you went to the job site to say, okay, we're going to be in this ditch or we're going to be working in this piece of equipment. Look at what's overhead. Do we feel comfortable with this?
Yeah.
And how do we ensure, you know what it is? Proactiveness versus reactive. You can be as proactive as you can be. Do all these things. The moment something changes, whether it be the weather, it could be to your point, maybe something falls or you have some uncontrolled, unanticipated event.
Yeah.
You go from proactive to reactive.
And when you start reactive, you're starting to make decisions
on the fly.
Based on what you have in front of you. And sometimes you still don't have all the proper information to make the right decisions.
Exactly.
And so that's a perfect example.
And then you have the aspect. You think of this. You're on the job site, you're working, you're sweaty, you're hot, it's Friday, you want to get home. We talked earlier about the emotional stress that we all go through. You could have been an argument at home. It could have been you had a near miss accident on the way there. You have all of these different items on top of you, and you have a procedure. You have done the plan, and now the plan has changed. how you react in an emotional state, in a state of fatigue. You're
Mhm.
tired. You could be mentally 100% there, but you're tired. You know,
Physically, it's hard to do that.
yeah, and then you have to stop and adjust. The important thing is to stop and think about it as a team,
Yeah.
not an individual.
Yeah.
You need to get more eyes on the situation, say, look, and I would rather somebody yell at
Mhm.
me
Yeah.
or get frustrated with me saying, you stop for this?
Yeah.
This is a no-brainer. Yeah, because
I
hey, where's my mindset right now? The
Mhm.
things aren't going the way I planned them to go.
Yeah.
I'm tired. I'm fatigued. I'm going to make a
Mhm.
mistake.
Yeah.
If I start thinking on the fly, I need another set of
Well,
eyes.
what you just mentioned there is, it goes back to the thoughts. Two heads is better than one. We're going to have different thoughts, and
Yeah.
even when I've planned some of these things, and I have these type of job briefings that's going to go on,
Mhm.
I may have in my mind, and I tell the people when I'm doing this, okay, this is what I anticipate. This is how I see it. This is the schedule of events that's going on. Now I know that I'm putting forth my plan for what's going on here. But what I need from you is I need your thoughts, and looking at it. Is this a good plan? Is there something that I'm overlooking that you know of? Is there something that we haven't considered yet that maybe we should? Because, I don't ever want to go into something without, having the other input. I mean, we look at, we talk about accidents, we talk about planes and stuff, and plane took off years ago and crashed into the river in
Mhm.
DC
I
because
remember that. Yeah.
the
Birds.
co-pilot, well, in this particular case, it was, the co-pilot, you know, did not agree with taking off, but the pilot said, let's take off. And what happened was, in that situation, the sensor, the planes, whatever, it went into the river. But what came out of that investigation was, as we talk about a stop work authority, we talk about consensus
Oh, yeah, yeah, yeah.
between
Yeah.
between people. So, in other words, I am not going to be the sole person
Right.
responsible for making the decision that's got a plane full of souls on it. That if my decision is wrong,
That's
we're going to
right.
go off. I want you as the co-pilot. Are you in agreement with my assessment of it's safe to take off and we're going to take off? And do you have any concerns?
Right.
Because if I don't invite you to open up with your concerns, with your experience, you know, this may be the first time I'm piloting a plane,
Yeah.
and
Yeah.
I mean,
Or you
we
could
all
have,
we always have first. So I
yeah,
mean,
or you could have been doing it for years and you overlooked a detail
yeah,
because familiarity can
complacency.
sometimes
Yeah.
breed complacency and contempt.
Yeah, and I think to that point too, and we're talking about we both proceed. Well, let's look at it from another standpoint. And the risk assessment procedure in 70 actually addresses it. It is, there are a lot of tasks that an individual may do by themselves. And it's, I remember back being a kid going and helping somebody, but the only reason I was there was just being a second person.
Right.
So when we look at 70E and we start following through the risk assessment procedure that they spelled out, that includes, is there a time when I need to ensure a second person is there with me? And we talk about, arc flash and if somebody is going to be in a situation, how do we perform, emergency rescue? How do we do contact release? How do we do all this other stuff
Sure.
in situations where I need a second person there with me while I'm doing
Yeah.
the work to watch out for me in the
Yes.
event an unforeseen incident occurs.
Right.
And it's
And here's what I love this. I love when someone will say,
hmm
you don't have to do that because what you just said shouldn't happen. Well, I
yeah,
know it shouldn't happen. And if something bad
yeah,
would never happen, then I wouldn't need PPE. I wouldn't need barriers. I wouldn't need GFCIs. I wouldn't need
mm,
arc reduction technologies. I wouldn't need a circuit breaker in a circuit if I never overloaded a circuit. Right?
yeah,
We plan for contingencies. We plan as best we can
mhm,
to be practical,
yeah,
to make sure that we have the protections in place based on codes and standards,
mhm.
and you can always go above and beyond, right?
Yep.
You can
And
always go above and
codes and
beyond.
standards are simply, it goes back to regulations. There's simply minimum standards that you have to
Yeah.
comply with. And I think where we found our successes is when we exceed those minimum standards. Some people say, well, that's the least I can do. And that's only because that's the least that they could do. No,
Yep.
the regulations are the least that you can do. It's you want to do over and above what is required.
Yes.
You want to provide that extra level of protection. You want to provide that and that contingency. I think you used the term contingency.
Mhm.
It's important that we look at the GFCIs, the arc fault circuit interrupters. These type of protective devices were designed to protect us from ourselves and from other situations that basically
It's a last resort.
it's the last resort. But it's one of the things that if that's not there, and I remember, I mean, and I'm going to say, my hat goes off to Ed Egan. He was an OSHA representative
Who?
in Ed Egan.
Oh, Ed Egan, yeah.
Ed Egan was an OSHA representative and trainer years ago. He was actually the first OSHA trainer that I took my OSHA safety training from.
Yeah.
And just to, look back, his claim to fame was, I always say claim to fame, but he was, I know he's featured on NBC Today one time when we were talking about this technology. GFCI is being added in the cord sets on hair dryers.
Oh, yeah.
You remember
Yeah, I
that?
remember that.
I
Yeah.
mean, I used to have a hair dryer that didn't have
Yeah.
a GFCI on the end of it.
Yeah.
And then all of a sudden, every portable hair dryer that you
Yeah.
have has an incorporated GFCI on the end of that receptacle, on the end of that plug. And that's part of where his legacy, he was all about we've got to provide things to protect people when they don't even know they need protecting.
That is so true. And I love, sitting on panel two, we do the GFCI things
Yeah.
and we have the GFCI requirements. And unfortunately, many of the requirements in 210.8 are written over statistics of people
Oh yeah.
who have succumbed to the ill effects of electricity. And when you decide to make a change that is not based upon a statistic, they'll say, "Show me a body count," or you can't make a requirement based upon something going. If they get electrocuted because of this, then they didn't follow these three rules.
Yeah.
Well, if you followed all the rules, you wouldn't need
We
anything.
wouldn't need any of it. So it
You know?
really is, and I think that that's where going back to the discussion we started with here today, the risk assessment procedures, and understanding how to do a proper job hazard analysis, how to do a proper, risk assessments, and to consider the probability, to consider the severity, to consider what's the equipment maintenance. We've got all these things that when we're doing the risk assessment for electrical equipment, for instance, we've got to make sure that this equipment's been maintained properly, it's been checked properly, it's been serviced properly according to manufacturer's instructions.
Yeah.
And we now have an NFPA 70B that says, hey, here's some recommended, here's a consistent standard now that tells us how we're supposed to monitor and conduct equipment maintenance, electrical equipment
Right.
maintenance. So, we do, if nobody can prove to me that that level of maintenance has been done, then there's no way in the world me as a qualified person can assume, because we don't like that word assume. So we know what that means.
Absolutely.
But we can't anticipate that this equipment is going to operate the way it's designed because we can't ensure that it's been maintained properly.
Yeah. And so the elements of a risk assessment is per 110.3H. One, identify the hazards, assess the risks, and then implement risk control according to the hierarchy of risk control methods. Our GFCI description was a part of that, but it was I think we fairly stated it's the last resort, right? To your point, informational note number one says the risk assessment procedure could include identifying when a second person could be required and the training and the equipment that person should have. And it could be a shepherd's hook of
It
some
could be.
sort,
It could
or
be.
or it could be that I need you to look out. I
Yeah.
need you to make sure that I don't have people walking because we're in a high
Yeah.
traffic area. I can't have anybody walking through the tape,
Mm-hmm.
and I need you here to make sure that that
Yeah.
doesn't happen because people are going to come down that hallway are definitely not qualified. They're not going to understand what this tape is, and we need to mitigate that risk.
For
And
you.
because the likelihood is high that somebody could walk into the boundary.
I had a situation years ago where it was critical. We had a plant, and it's a water plant to provide water to city that, we can't really shut the power off at that point in time. And in a sense that if we shut the water off, then the city in that area loses water protection for fires and everything else. So we have some justification on why we cannot, you know, turn everything off for us to do what we want
Yeah,
to do.
yeah.
So it's a situation where in that situation we do a risk assessment. We have to measure some stuff to get stuff fabricated to fit into it. And at that point in time, the qualified workers that were on the job, including myself, as a safety director, safety professional, I'm there. I'm, considered a qualified person because of my background, my experience, and my responsibilities to ensure this that. And to that point, what happens? The general contractor, construction manager, safety guy, he comes walking in the door. He opens the door, and first thing he wants to do is walk down behind the gear where we're at
Yeah.
and check and see what we're doing. And I mean, I hate to say I had to be rude. I mean, here's a guy that I'm friends with and do it, but I had to yell and scream at him, for him to stop what he was doing, stop where he was at, turn around and get out. He's not qualified
Yeah.
to be in there while we're doing that work. I will tell you later when we get done with this, but I can't have you in this situation right now because two things. You're already interfering with what our work assessment and risk assessment and job briefing has done.
Right.
And we're not here to protect you in this situation. We've got to protect everything else that's going on. And we don't need any outside distractions that's going to cause us to make a miscalculation.
Yeah.
He was
Yeah.
he was a little bit concerned, and he left. And after we was all said and done, I had to go sit down with him, and I said, "Hey, look, friend, I appreciate all you've done, but here's the situation. You're not qualified to be that there in the back of 480-volt switchgear with a 3,000 amp main. You're not wearing the proper PPE equipment. You're not wearing the
Mhm.
proper garments that we had on. You're not wearing the proper rubber gloves. And oh, by the way, you bought these fancy new hard hats called that have ventilation holes in them that are cooler in the South Florida area, but you have ventilation holes in them, which means they're a type C hard hat. They're not allowed to be used around electrical circuits, energized circuits. So you're going to have the type G, which is good for a couple thousand volts, or a
Wow.
type E, which is good for 20,000 volts.
Yeah.
Utility
Detail devil's in the
So
details.
it's in the details,
Yeah.
and it's like, well, I could, and so a lot of times in those situations, what we find ourselves as safety professionals, even doing these risk assessments, is we really have an opportunity and a responsibility many times to educate
Mhm.
our compadres, our other safety professionals that work for other
Yeah.
contractors and in other areas, because there's a lot of situations that they may not have been exposed to, and electrical is one of them. I mean,
Yep. Yep.
we don't expect, and I don't anticipate anybody just because they're a safety professional that they automatically know and understand electrical hazards.
Right.
That is a unique hazard that, you know, we get our safety professionals usually from the field, or we bring somebody in and we teach them the
Yep.
electrical aspect and the electrical trade so they know exactly how to address the hazards related to the electrical
Absolutely.
installations. Anytime that you go in to do a project, and we do a lot of what we can changeovers, shutdowns, things that, have we can plan to the nth degree, but it's not how we handle the stuff that we've planned for. It's how we handle the stuff that comes up that we haven't planned for, which is going to determine the total outcome and the
That's right.
success of that project.
No, you're
Because
absolutely right.
because there is going to be something, and I hate to say it, it's human nature. We talk about human error. We talk about the ability to
Boom.
have,
That's number two.
we talk about human error. I mean, we're all fallible. We're all capable of making a mistake.
Yep. And 110.3H2
Yeah.
is titled Human Error. And this is what it says: the risk assessment procedure shall address the potential for human error and its negative consequences on people, processes, the work environment, and equipment relative to the electrical hazard in the workplace. Now,
Yeah. I mean, and the other thing that goes in along with that same discussion, I know we're going to be kind of wrapping these things up here in a minute, but when we talk about human error, and the one phrase that always I stress a lot of time is that phrase, normalization of deviation. Where
say that again.
normalization of deviation.
Okay.
And what it is all of a sudden we get used to taking these small little deviances from what we normally would do.
Mm-hmm.
And then instead of it becoming the exception, now all of a sudden
It becomes the norm.
it becomes the norm.
Yeah.
So we've normalized the deviation that we've done to a point that, all right, it's normal to take a shortcut. It's normal to do that.
You know
Or
where
if
that's
it's normal to do that, then the next time
yes.
I'm going to deviate from it again, but now this time is a little, and sooner or later you get to that point where it you know, it fails, and you ask yourself, how did I get to this point? The other thing that just to wrap up with today, we're talking about, I think you mentioned again earlier about hierarchy of controls, and I think that
Yeah.
when we look at that from a risk assessment standpoint, we know that if we eliminate a hazard, if we eliminate the hazard,
Mm-hmm.
we have no hazard to protect ourselves from, or protect our workers from, because we've eliminated that hazard.
That's true. Yes.
And I think that that's really the ultimate goal here when we start doing the risk assessments is what can we do to eliminate the hazard to where, hey, I don't need a guardrail. I don't need
That's right.
a deviation. I don't need um, established. I have protected it because I have eliminated the hazard, the possibility of a hazard. Elimination, substitution, awareness. Then we get into engineering controls, administrative controls, and PPE,
Yeah.
and all the things that make up that pyramid.
Mm-hmm.
But we're looking at well, if we can eliminate the hazard, we don't have a hazard protection. Well, if we can substitute something in that situation,
Sure.
such as I'm old enough. I hate to tell you how old I am. A lot older than I look, but I can go back to industrial controls that used 480 volts for start, stop, push buttons.
Mm-hmm. Mm-hmm.
Okay, and that's in an industrial plant. An industrial plant
Yeah.
with 480 volts control voltage
Yeah.
for the start, stop, push button.
Wow. Yeah.
That's pretty dangerous now.
That
Isn't it?
is. Now, what do we do? Substitute that with
24 volts.
amen. Down
24
below
volts,
below the shock threshold.
But below the shock threshold.
Uh-huh.
But what we can't do that. We substituted it. But the reason that we haven't eliminated the hazard is because now, just because we have reduced the voltage and substituted it, well, I can still cause a misoperation of that.
Oh, that's a good point.
Because I even though I've substituted with a lower voltage, what's going to happen if I short something out or push a button or whatever? I could still inadvertently start a piece of equipment.
Oh man, you know what, man?
Yeah.
I tell you what, that you just blew the doors off of my car. Because I always talk about, that's one of my examples. I say, look, we can eliminate the hazard by going from the 480 to the 24 volts, but I never thought about what would happen if that was controlling something that could hurt somebody. That can still happen. So I haven't eliminated the hazard.
You haven't eliminated. You only substituted the hazard.
Wow.
So anyway, those are some things to really think about. But Tom, I just really appreciate the opportunity to have these assessments with you. And I know that, over the years, and like I say, going back to my field days, I've installed equipment from manufacturers, and, I commend NEMA, I commend the National Electrical Manufacturers Association,
Mm-hmm.
whether it's Eaton, whether it's Square D, whether it's GE, all the advances that they have made in the name of safety and to protect the workers over the years. I mean, your arc mode reduction, it goes back to we need a fuse that's going to open up quick.
Yeah.
And okay, well, we got a fuse. Now we've got an arc mode breaker over here, electronically sensing that opens up as quicker.
Yeah.
And that's each time we're making that technology and doing it just a little bit better.
Yeah.
And each time we do it a little bit better, we're making it safer for our workers. So, I mean, I got to say thank you to Ethan. Thank you to the opportunity to be here, and thank you to
Thank you.
for your participation and in the code process and IEEE and I look forward to some of the papers you've talked about here to
Yeah.
see at ESW and stuff like that. So with that,
Absolutely. And I want to make sure everybody out there knows Safety Roundup. You can catch this guy. Those are recorded, right?
yeah, those are all recorded. We have them all recorded on the website. They're we have links there. And in Safety Roundup, we have the outside executive director of safety, Mike Starner for NECA. Me and him, we talk to industry representatives. We talk to, we've talked to OSHA, we've talked to ASSP, we've talked to, a lot of, the Electrical Training Alliance personnel. We've talked to a lot of industry representatives, and we're going to continue that. I mean, and we'll have Tom on one of our calls, but when I do that, I'm going to make sure that I bring Mike in with me so we can tag team and double team, and we're really going to give it to Tom on that particular day. He's going to have to be on point
I can
to
take
be
it.
able to handle
I got
Mike
this.
Starner and Wes Wheeler in the NECA Safety Roundup.
I love it. Be there or be square.
Thank you.
Thank you. Thank you, Wes. I appreciate it.
Thank you.
You're a man. Thank you.